Hey guys, welcome to Pre-Calc Lesson 3.1, Interpreting Finite Graphs. Before we actually get to the graphs, let's talk about some vocab here. If you're asked to find where a maximum or minimum occurs, they want an x value. If you want to know what the maximum or minimum is, that's going to be the y value. And that word value simply represents a number. Okay, not a coordinate. All right, well, new here for us is a relative minimum and a relative maximum. I don't believe we talked about this in Algebra 2. So a relative minimum is simply the lowest point on a sub-interval. Think of it as a valley. So it would kind of look like this. For a portion of the graph, you see this valley here. The lowest point of that valley would be a relative minimum. It's called relative because it's relative to the points on the left and right of it. So you guys can probably figure out relative maximum is going to be the highest point on a sub-interval. And think of this as a peak. All right, so the graph's going to kind of look like this, and that peak right there is called a relative max. Again, because it's the highest point relative to the left and right. Next, we've got two types of notation we're going to be using in this unit. Interval notation, I'm sure you guys are familiar with. We didn't use it a lot in the first couple of units, but we're going to be using it more here. So this is a number line, and this is the interval that's shaded on the number line. Now I want to express this with interval notation. I'm going to say x is an element of the interval from 3 to infinity. So a couple things to notice here. The bracket represents a closed circle. If I were to make this an open circle, this would have to have parentheses around it. The other thing to notice, infinity will always have parentheses because you can never reach it. So always open, always parentheses. Set notation. So let's talk about the same interval here. So let's say this is what you have on your number line. How do you write that in set notation? Well, that's pretty easy. You're just going to say x is greater than or equal to 3. Sometimes you'll be asked for specific notation like either interval or set. Sometimes it just leaves it up to you. It's great to know both because sometimes interval notation is a little bit easier to use if you have the choice, and other times set notation is. All right, let's get into some examples. Hopefully largely review. Given the graph of f of x, answer the following. Use set notation. So they want us to use that set notation here. So look at the graph. Okay, I don't know what the equation is, but I don't need to know because I'm going to answer all these graphically. This is off a little bit. I'm going to assume it ends right there at that coordinate, and this one ends there. So no arrows, okay? Finite ends here and here. State the domain. Well, if you remember, domain, we want to know what x values are included on this graph. So that means I want this here. There are the x values. So I need to state this interval in set notation. So it looks like -5 is less than or equal to x is less than or equal to 5. Now I need to state the range. All right, let me go to a different color here. Range will be the y values. So the y values, what you want to do, and this is important, you don't want to use the endpoints necessarily. Y values would be the maximum. So it looks like this right here is the maximum, and this right here is the minimum. So this is the range here. So my lowest looks like -3 up to 4 inclusive. So this would be -3 is less than or equal to y is less than or equal to 4. State the roots. The roots are where it crosses the x-axis. So here's one, and here's one. That is it. There are 3 roots. I just there's a couple ways you can do this. I like to just go x equals and write the roots down. So -4, -2, and 1. You could also use a set notation there with the braces, whatever's easiest for you. So now the next one's pretty important. Where is f of x greater than 0? So remember what this means. That means above the x-axis. So if I'm going to highlight where it's above, here's my x-axis. Any piece that's above that is going to be greater than 0. So if I highlight it, now it doesn't say or equal to, so it's open circle, and I want this piece here, open circle. I want all of this. Now be careful, this endpoint is included. That point is above the x-axis. All right, so how do I write that? Looks like I have -4 is less than x is less than -2. All right, so this represents that interval right there. Or, now I need to represent this interval. Wow, that looks like a 1 to 5, but notice this is open, but that's closed. So that's going to give me -1 is less than x is less than or equal to 5. So those two intervals right there represent where this function is greater than 0. Okay, next example. Start going a little bit faster here. Once again, I want you to notice these are endpoints, not arrows. So they terminate at those two positions. Where is h of x greater than or equal to 0? So greater than or equal to 0 means above or on the x-axis. And you don't have to write this out. I'm just kind of going slow here. Above or on the x-axis. Well, check this out. Above, 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 on, and then all of this stuff here is above. So all of this is above the x-axis or on. All right, well, that's going to be -5 is less than or equal to x is less than or equal to 3. It's the whole thing. Now, this is new. Where is h of x increasing? So increasing means going up. It's like a roller coaster. So as you go left to right, are you increasing? Well, follow along here. Decreasing, 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 neither. Increasing, 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 neither. Decreasing, neither, and then increasing. So if I just highlight the parts that are increasing, it would be from here to here, and those will be open because you're not increasing or decreasing, and then from here to here. And again, those are always open because I don't know technically what's going to happen here. So that's going to be open to there, and those are increasing. Okay, I'll actually highlight it with the marker. Open circle to here, open. All right, so I need to represent that in set notation. That's going to give me -4 is less than x is less than -2, or 0 is less than x is less than 3. Okay, all right, let me erase that. Where is h of x decreasing? So decreasing means going downhill. Downhill to here, downhill to there, and then we stop. All right, so I'll pick up a different color. Open circle going downhill. That's neither. Open circle, we go downhill, and that's neither. So how do I write those two intervals? It looks like -5 is less than x is less than -4, or -2 is less than x is less than 0. Where does the minimum value occur? Where does it occur? That's an x value. So you just trace your whole function, and the minimum is the absolute lowest point. That is the minimum point. Where does it occur? When x equals -4. All right, a couple more quick ones. Given the graph of g of x, answer the following. What is the minimum value? So now this question wants the minimum value. Remember, that's just going to be a number. All right, so again, you trace the whole thing, and the very lowest point is there. The value is this. So that's going to be y equals -2. State the coordinates. So again, vocab, coordinates, you want ordered pair of the relative minimums. Relative minimums, remember, would be your valleys. So here's a valley. That means there's 1 relative minimum. That's negative 3, 1. Where's another value? Right here. That looks like 2, negative 2. Next, state the coordinates of the relative maximums. So relative maximums are going to be your peaks, your hilltops. There's a hilltop, and that's the only one. All right, notice, that's not a relative maximum because we don't know what's going to happen as we continue. I can't see what's happening relative to that point on both sides. Same as this right here, sorry. So there's only one relative max right there. Okay, let me erase that as I can't really tell. I'm going to assume it's this coordinate right there. So negative 1, 3. Where does the maximum occur? So notice the difference in the vocab. The maximum, you just look for the very highest point. Nope, right here. So that is the maximum. Where does it occur is going to be an x value, and it looks like that's going to be negative 5. All right, last one. Now I get to use interval notation. So don't forget about this. Where does the maximum occur? So again, I don't care about a peak on that. I just look for the highest point on the graph. That's right there. Looks like that occurs when x is 0. Where is f of x increasing? So where is it going uphill? Open circle, because at a relative maximum, you're neither increasing nor decreasing. So I'm going uphill, 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 neither. Then I go downhill. Then starting here, I go uphill again to this point. So I want to write that in interval notation. X is going to be an element of parentheses negative 4, and it stops at 0. Union, that's what that U means, 4 to 6. Now notice, I like you to add this x an element of, just so you don't confuse the interval notation with coordinates. And that's one of the disadvantages of interval notation when you're going back and forth between coordinates and intervals. It's easy to get them mixed up. But this is not a coordinate. That's an interval from negative 4 to 0. That's this interval right here. What is the minimum value? So that means a number. And it looks like it's right here, negative 5. Y equals negative 5. Where is f of x greater than 0? So that means positive. That basically means above the x-axis. All right, let me erase the stuff I've highlighted already here. So where is that above the x-axis? Well, not here, but it's going to be an open circle. All of this is above, 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 and that's an open circle. And then this point is not above, and that point is not above. And notice it doesn't say or equal to, so I can't include those. That's going to give me x is an element of the interval, parentheses, negative 2 to 2 with parentheses, because those are open circles. And then finally, where is f of x equal to 0? Basically, that's another way of asking for roots. So that's a root, that's a root, that's a root, and that's a root. X equals negative 5, negative 2, 2, and 6. All right, so that concludes the notes for day 1. Don't hesitate to reach out if you have any questions, and thanks for watching.